Let's graph this piecewise using point slope method. First, we need to find our boundaries. Using our boundary equations, inequalities, we're going to look at where our boundaries are. In the first piece, we get -7 and -5. From -5 is less than x is less than or equal to 5. We get the boundaries -5 and +5. From 5 is less than x is less than 8. We get the boundaries 5 and 8. What we now need to do is we need to figure out whether we're open or closed. -7 was open. -5 had an equals to, so he was closed in the first formula. -5 is open. +5 is closed in the second formula. Finally, +5 is open and +8 is open in the third formula. Now we're going to find our boundary points. So we're going to use the boundaries for our first expression. F of x equals 2x plus 6. We're going to find f of -7, and we're going to find f of -5. Why? Because those were boundary points. F of -7, 2 parenthesis x plus 6. That parenthesis is going to swap with -7. Replace that -7 with -5. This is linear. So I can use point slope method. Here is a point. Here is a slope. Second section, f at x is -1/5 x. We need our boundaries. Our boundaries were here. -5 and 5. Setting up my calculator, (1/5) parenthesis for x. First one, -5 goes in. I get 1. Replace -5 with +5. I get -1. This is linear, so I can use point slope. Here's my slope. Here's a point. Last boundary, f at x equals 5. We're going to use the boundaries, 5 and 8. Setting up my calculator, 5, no parentheses, no x. So when I plug in 5, there's nothing to swap. I hit enter. Go back. Substitute parentheses, no parentheses. Hit enter. 5. Now we need to sketch our graph. My boundary points, -7, -8 is open because the domain was open. This one is closed. Open, closed, open, open. This helps me know where to put my points and how they're going to look. Now I'm going to sketch in my boundary line. 1, 2, 3, 4, 5, 6, 7 negative. Boundary line 1. Boundary line 2. Boundary line 2. Boundary line 3. Boundary line 3, boundary line 4. Okay. First boundary right here. Second boundary is this section. Third boundary, that section. Now I can graph my points because they're linear. This is actually linear. It's called a constant function. That means m is 0, no slope. All right, so now I'm going to graph my points. This is the point, -7, -8. Open. -5, -4. Close. Linear equation. Check my slope. 2. Rise 2, right 1. Rise 2, right 1. Connected. Point, slope. Next boundary. Start at -5, 1. Open point, because it was open here. If you cover it up too much, make him bigger so you remember he's open. And 5, -1. Closed. Slope, -1/5. Down 1, right 5. Down 1, right 5. Point, slope, check. There's my equation. Last one. 5, 5. Open. 8, 5. Open. Slope, nothing. Rise 0, right 1. Rise 0, right 1. Rise 0, right 1. Point, slope, check. Done. Our answer is just the black. So we can take and put -7, -8, -5, -4, -5, 1, 5, -1, 5, 5, 8, 5. And we will see that our answer can be cleaned up. Final answer. We start at -7, -8, open. We end at -5, -4, closed. We then pick it up at -5, 1, open. We end at +5, -1, closed. We pick it up at 5, 5, open. We end at 8, 5, open. There was our answer. From here, we can figure out our domain and our range, which is a good practice to do. Domain, we're going to look left to right. The first place, if I'm holding through the x-axis, I hit any of my graph is at -7. I'm going to go through until I end this piece. I'm going to check, oh, point down here, open here, still part of a function, keep going. Now I'm in the middle, happens to continue. Stop here. Do I have somewhere to pick it up? Yes. Closed, open, still function, keep going. Where do I stop? 8. -7 was open, -8 was open. Range is a little bit trickier. We're going to start down at the bottom, the lowest we can go. So the lowest I can get to is -8. Open. Then I'm going to travel up until I end any part of my graph. And if I look here, I'm at -4. But if I go up, there is 0 graph going left to right. 0 graph going left to right. So we have a gap. He's closed, so he's squared. So because I'm going to have to pick up my pen to get to the next highest point, we're going to be at -1. And we'll continue until we hit +1. And then if I go any higher, there's no graph here. So we have a new section. Close at -1, open at +1. And then I pick up my graph at 5, and as soon as I go up any higher, it's gone. Open here but closed here. If this squished onto the x-axis, or the y-axis here, it would end up filling itself in at 5. So our answer looks like this for the range.